All right, I hit the buttons. Is this stream number 4? Cool. All right. So I added a couple buttons to the keyboard today. Just kidding. So this is a little breadboard I had the microcontroller on, and I have 2 keys wired to it. Before the stream, I went and soldered pins to... hold on, let me see if I can get a good shot of this. I'm not used to doing this. It's hard to see in there, but yeah, you can see the sockets, the Kyle sockets at the bottom of the switches. I soldered header pins to them so that I can plug them into this breadboard. And then I have wired the tops to, hold on, to D10, GPIO 10, and the bottoms to GPIOs 8 and 9. So I'm thinking of doing a 2-column arrangement with a single row. Is that right? We can try both. We can try that the top is a row and the bottom is columns, or we can try the top is columns and the bottom is a row. We can try it both ways. The objective is that when you press one, you detect it and not the other. I'm not using any diodes because I don't have enough keys to have a ghosting issue. So 2 things I want to accomplish today. I want to have a basic key scanning routine in there, and I would like to see if there's any bouncing that I have to debounce. Hey there, Endorn. For me, it's Sunday, so I get to stream during the day where normally I would be working. So, what was I going to say? Right. To do the debouncing, I kind of want to have a handle on how much time is elapsing. And so I want to also figure out how to use that timer right now that we're using for delays. I kind of want to use it to get a counter so that we can kind of take differences between counts and then print out durations in microseconds or milliseconds or what. Yeah, the bot's back. You made a typo. Yes, you did. You didn't make a typo that time. Okay, so without further ado, I gotta program D8, 9, and 10. I think we'll start with something simple where we'll just see if the pin is high or low. And we'll do that in the same loop that we're processing the NeoPixel. Did you screw it up, Endorn? Typo is the command. Typo is not. Okay, now you gotta type typo. No, you already added it. Here, let me help you. Did you mean typo? Okay. Oh, one thing I did between the streams also is I looked to see if the NeoPixel pin had a alias, and it doesn't. It's just D11, which is kind of weird to me because in the CircuitPython they have a name button, and NeoPixel, which they have here. I thought they did. Yeah, they have a name NeoPixel for 17, but for 11 they just have D11, where they could have called it button. I think that would be a better name for this board. So yeah, we're going to use D8, 9, and 10. So the way I have it wired, both buttons are wired to D10. So let's do a single row. So the D10 will be our row, and the 8 and 9 will be columns. So the idea is that we configure D10 as an input, the row as an input, and then 8 and 9 as columns. They will be outputs, and they will be usually driving a high signal, but then we want to select a column, we'll drive it low. Oh, and the row will be weakly pulled up high. the row input will have an internal pull up resistor. I looked this up, Endor. So most electrical engineers use pull ups because you want the long wire. Like if you have a key on the edge and you have a wire all the way back to control, you want that to be ground when active, not power when active. It's better for noise, and it's also better if you happen to have any shorts. Usually you have more ground points than you have VCC points. So it's just a convention or a way that most electrical engineers do it is they'll have pull-ups and then buttons will ground. So yeah, the microprocessor we have to make sure I have configure pull-up resistors on, otherwise I will short the board. So maybe that's what I do first is we're going to configure pin D10 as a pull-up input. Configure GPIO 10 as an input with internal pull-up. Hey there, meme clear BAMs. In your projects there are pull downs. You can do it either way. It's just, in fact, that's why I had to look it up, because I'm like, what do most people do? Pull ups or pull downs? I think Q and K uses pull downs. No, they also use pull ups, but in write-ups that I found, they talk about doing it the other way. So it's sort of inconsistently applied. So we're going to call this one the row. We'll give it a number, because in the future maybe I'll have more than one row. And we're on D10, right? That's the one I have wired. Yes, that's the one that they're commonly on. Into not floating input, pull up input. There we go. Okay, and then configure GPIO 8 and 9 as outputs. Driven high. So let call 0 D8 into push pull output. Is that what we want? Let's push pull output. Push pull output. As opposed to what, a common drain output? I guess. All right, and then column 1 is going to be D9, right? D9. So that's my green wire. If we were to add a typo counter, would it need to be U816 or would it be U32? I think it would have to be U64, Endurin. Yeah. If I get too frustrated with my Corn keyboard, I switch back to my Kinesis with its, which is right now in QWERTY, and then it takes some pressure off. No U128. Okay, so we have those configured. I want to drive them low. Do I need to... No, I get a pin directly. Why is there an as mute as ref? Set drive strength? Do I need to set drive strength? Probably not. Okay, how do I just do push? I thought it would be like set something, like set high, set low. Oh, there we go, set high. Use one of the split keyboards, right? Yep. So, using this, the Corn keyboard that I had built for me, like in January. And it's in Colmac DH, or mod DH. So I haven't assigned keyboard yet, Endorn, because I think keyboard will turn into the real keyboard I'm using, so I have it set as corn right now. Yeah. So I kind of copied what Adam did, only instead of building it myself, I just had it built. But Adam recommended to me a site where you can kind of get one made to order. And so I did something kind of foolish. I both got this 38 key keyboard and switched layouts at the same time. So it might have been a little bit smarter to first get used to QWERTY with layers and then go to Colmac, but I don't know. I don't know what I was thinking. I guess I was thinking that part of the keyboard experience would be doing both at the same time for whatever reason. It is confusing. So not only are my numbers on a different layer, so my symbols are on yet another layer, and to move the cursor around is yet another layer. And the arrangement of the letters in the layout I picked is not what I was used to before. So it's like I just made all these things much more hard on myself than I needed them to be. I don't know, maybe I'm a glutton for punishment. Okay, so this is the initial, right? Why is this giving me a warning? We're just going to drop the results. I'm wondering why would it ever give us a failure? Oh, you can't drop it? Wait. Then what? It wasn't returning a result? They're returning a result. I don't get it. Okay, well, we'll just do the old way. Let underscore equal. I guess I could unwrap them, but eh. Hey there, Ramy. How are you doing? Finally catching a keyboard stream because I'm actually streaming during EU-friendly hours for once. QWFPB is the top layer. No, well, it's yeah, yes. QWFPB, and then the other side JLUY semicolon. Took you a month and a half to get used to the Colmac DH. You never go back to QWERTY. It's taken me 6 months to get about 80 words per minute on monkey type, but I still make lots of mistakes. So I don't know if that qualifies as getting used to it. Of course, I made mistakes on QWERTY too. It's hard to it's all subjective. What does it mean? Does it mean comfortable? Because I'm still not comfortable programming. I'm comfortable doing English text because that's what I've been training on. Which is maybe a mistake. Maybe I should have been training while programming. Gonna go to bed soon, so you'll be around. Oh, that's okay. You can see my 2-key keyboard. Hey there, Nui. How are you doing? It's 10. You guys to go to bed before midnight? What's wrong with you? You're young people. Aren't you supposed to stay up till 2 in the morning? I guess you have to work tomorrow. So yeah, look, I have a 2-key keyboard now. It was a 0-key keyboard last time. We're gonna try to wire up this matrix. So the idea is we're gonna read row 0 after setting column 0 low and then column 1 low. And let's remove the use of the button. Actually, let's just comment it out for a second. So let's set up key codes here. Six. And then we'll just put them in here. All right. let's, I don't know. I'm not really thinking too rusty here. I'm thinking more C, where we would have sort of like an index. And as we see the keys are held down, we would put them in key codes at that index and increment the index. What's the name of this project keyboard? It's called the Rusty keyboard. Although my kids told me I should have named the one from last stream the Q board, because it types Q when I press this button. It's the Q board. But we're making it no longer the Q board. I wired 2 keys on and they're like, oh, is it now the QW board? Your top row starts with A, B, C, D, E, F, G, R, C. Have an alphabetical order. You animal. You type all this on an old 9-key keyboard with 1, A, B, C, 2, D, E, F. Have you seen the YouTube video of, I forget the guy's name, but he has a 14-key keyboard, so 7 on each side. So 6 plus a thumb on each side. Actually, no, it was 2 thumbs, so that means it's 16 keys. People in his comments were saying, well, you just got to go to 1 key and do Morse code now. All right, so first we're going to drop column 0 down, right? Set low. It probably would make more sense to have these just do unwrap, right? And then we're going to read the row. So let key 0 equal row 0 dot is high is low, right? Then we gotta drive column 0 high again, and then drive column 1 low, and then read row 0 again. And then finally we got to drive column 1 high again, right? So if key 0, key codes I equals 20, right? And then I plus equal 1. And then if key 1 is held down, we're going to add the key, whatever. What's the key? What's W? I should have bookmarked this. I don't think I did. I didn't. Oh, I did. I have it under notes for some reason. Tap 1 3 times equals C. Yeah, there we go. SOS. You only have 5 fingers. You only need really 1 key. Hey there, TS. Jost, how are you doing? Might be 2-key keyboard. It will be. Hold on. So 20 was what? 1. Yeah, it's wherever Q is, right? 14. So where's W? So that's 16 plus 10, 26. There we go. If let OK key. So many typing mistakes. If I slow down typing, I'll probably like fewer mistakes, right? There we go. I did it. You prefer to use the decimal values or the hexadecimal values? I don't know. I guess I was doing decimal because I don't have to worry about putting the 0x. It doesn't really matter right now. This is all sort of like experimentation, right? Build. Let's put it into bootloader mode right now. Those are the last cues that we'll ever see. Flash. Alright, did it work? Oh! The cue worked. The other key's not working though. Ah! Okay, what did I do wrong on this other key? Is it wire just loose? Nope. I don't know what I did on that key. Alright. It's still the keyboard. I must have messed up column 1 somehow. Let's review. D9, right? D9, someone on the end, yes. Push, pull output, set high. Alright. Set high and set low. So set high will drive it with 3 volts. Set low will connect it to ground. Oh, there we go. That should be 1. Oh wait, no. Sorry, I'm getting confused. They're all in the same row, right? It's if column 1 is grounded and then you hit the key, then that will send a 0 to the row. Just to make sure I didn't really screw this up, what if I just flip these around? This shouldn't really change anything, right? Flash. Flask? Flash. Nope, there's something about the order in these things. Okay, so there's a bug here somewhere and I'm just not seeing it for some reason. Okay, let's try to find the bug. I did make a 2x1 matrix, yes. So what did I do wrong here? Let's comment this. Scan column 0. This is scan column 1. This is send the keyboard report. Okay, what did I do wrong here? This one works, but then this doesn't. Do I need to have maybe delay between setting things high and low? Because this is running at 125 megahertz. I don't know how long it takes these things to switch. Should they be high or low? High if you're not pressing them, low if you are. Because pressing the key down completes the circuit. And so if we're driving the column low, then the row will be low. If you're pressing the key, right? If you're not pressing the key, then because row 0 has a pull up, it will be high. The initial states should all be high. So that's why we're going back to the initial states there and here. So everything is high to begin with, and we only drive it low when we're scanning that column. Set to 144 hertz for maximum gaming performance. Yeah, when we're scanning very, very, very quickly, I think. It's scanning as fast as it can check the timer to see if we've it's ready. We're using this timer down here to blink the LED. That's where all our work is actually happening. Overclock your keyboard and motherboard. Keep mouse and keyboard. Oh, I should comment this, right? Check for a report from the host. Report from the host has like caps lock and stuff like that. So I know independently the keys work. I'm guessing there's some kind of switching delay. Iterate over all the key code elements once set. Well, this is within the loop, right? Of this loop. So this loop happens very, very, very often, like millions of times per second, right? I'm thinking we're not waiting after switching these outputs. So let me think about this. If we're not waiting, well, no, then we wouldn't have been able to read the key if, so the set low and high must be really fast. So, okay. What is it then? I guess I could put a busy loop in between these two. Or I can set them both low. And then either one will trigger the key. We just won't know which key it is. No, that's not a good idea because it doesn't tell me. I can't test the two keys independently, right? Well, hold on. Let's just do it. So if I were to do this and then just skip this stuff. So it's driving both columns low. So if either key is pressed, it'll be a Q here. Ba-da. Ba-da. Oh, no, that's not true. Well, that's wacky. I'm driving both columns low. So either key I pressed should have triggered the row. Okay, I don't know. There must be some bug I'm not seeing here. It's not that the wires are loose, right? That one definitely works. I actually don't even think I need to worry about debouncing. Is your circle right? Have you tested the right key? Swap the wires of the keys? I can do that. So I'm just going to unplug this one. This one works. Now I'll just move it over to this other key. Yeah, that one works. Okay. Is it just something wrong with that GPIO then? Okay, yeah, there's something wrong with GPIO 9. I thought it was working before though. Something wrong with that GPIO. 9. Hey there, Anki Luke. Trying to get my 2-key keyboard working. Let's put it back to here. It's kind of hard to reach in there and reset it now. Ba-da. Ba-da. Okay, so if I move this one over to here, I can press W now. No, that one's the Q, and then W just doesn't work. So column 1 just doesn't work at all. I thought I had it working by switching the scanning order, though. Didn't I do this and then W worked? Right? Ba-da. 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 Yeah, see, now W works. That's wacky. Now GPIO 9 works and the other one doesn't. Huh. Just checking something on my bot. My bot doesn't actually say what people said, so I don't even know what that person said, Endurn. How low level am I? Implementing USB communication from scratch? No. I'm kind of like on top of some firmware libraries made by the RSRP people of byfollowers and such, so you can ban them, that's fine. So when I was on vacation a couple weeks ago, I was playing around with the Raspberry Pi Zero, and there I was on bare metal. But on the RP2040, there are crates made by the RPRS people. So Cortex-M, Cortex-MRT, and then there's even a board support package for this board. And so I'm based on top of those libraries, and so it's not quite bare metal. There are some abstractions. So, for example, there's this USB, where is it? There's this USB bus that's provided by the RP2040 HAL, and that implements the USB bus trait, which then you can use with this allocator, which builds the whole stack. All right. Good night, Rami. All right. Did I miss any questions? Work with the left key? Yeah, it's weird. It seems like the first key that I pull works, and then the second one doesn't. Which kind of suggests to me that I need a delay between the two, but why would I? Oh, maybe it's because it takes this input time to settle, right? That's probably what it is. In fact, can I hold both buttons down? Yep. When I release Q, I get a W. Sometimes when I press it. Yes, so I think I'm not giving the input enough time to settle from one state to the other. Let's move this back, and I'm going to add like a hard-coded loop in there. I don't know how long to wait for. There's a trick you can do that I learned while doing the bare metal programming, where if you do this and you just have an empty assembly, it will not remove it when you optimize it. Oh, Cortex M as an ASM? Sure, we'll pull that in. Oh, maybe not. Core Arch ASM. I guess we have to have an empty string. All right, so then how many times to loop? How about 10,000? That's probably enough, right? Right, now we have a 10,000. We have the microprocessor loop 10,000 times between scanning the two columns. Ba-da. Ba-da. Nope, still not working. Running a no-up? Yeah, it's a no-up. Do you have a spec on what the ramp-up, ramp-down time, the actual power going from low, high, and back? No, I don't. We could probably find it. What happens if you press them both at the same time? Yeah, that's what we were doing before. Now when I hold down 1, it stays held down. Actually, it's repeating now. Yeah, the other one's just dead. And it's not the wiring. Okay, we'll figure this out. Should I wait 1 million loops? My theory could be totally wrong too. I'm not saying I know. Ba-da. Ba-da. Oh, it's malfunctioning. I think it's taking too long now between loops. Okay. Ba-da. This is probably not it then. Ba-da. No, that's not it. It's not that we're taking, we need to have a delay between these two. That's obviously not it. Okay, so what else could it be? But yeah, that's so that you don't think it's your USB that's making those sounds. Do I need a loop between these two, maybe? Because it's going from high to low. That might be it. Okay, let me try a small loop between these two. Let's just make it 10,000. For now. Ba-da. Flash. Ba-da. Oh, that was it. Okay. I think I understand what's going on now. When we drive a column low and we immediately read the input, it's so fast that it doesn't, that the input hasn't dropped down low enough to detect as low. But the reason why the first key would work is, I'm guessing that you were holding it down long enough where that circuit, no, that doesn't make sense. I was going to say that circuit remains closed long enough, but there's still this transition from the high that we set the previous time to the lower setting at this time. Why would putting a delay fix only the second key, and why would we not need this one? Mysterious. Maybe that, okay, it could be that GPIO is just faster. GPIO 8 is faster. But hey, look, I got 2 keys now. If I hold them down, it should repeat, right? Yeah. Oh, we can't. That's weird. Okay, there's something going on here. If I press Q and if I press W and then Q, then we get an alias on W. If I press Q, I can't press W. See how W is, it's detecting extra W's? It should only be seeing the Q's. Could that be the way I'm doing these scans? I wonder if, like, if the W moves between the two positions in this key codes, does it think that it's a new key? So to test that theory, instead of writing to I, we'll just write to 0 always there and write to 1 always there. Yeah, let's do that.
Bada.
Flash.
Bada.
My switch is sort of tilting out of it. Okay, it's still doing that thing where it's repeating the W. So that didn't fix it at all. So that's not it. There's some other kind of weird thing going on here. I wonder if it's this thing again. How about a delay after every time we set something high or low? We probably don't need one after that. So every time we change the state of an output, we're going to do a delay. To give the line time to settle.
Bada. Bada.
Nope, that didn't fix it. Actually, you know what would be a better tool is the QMK thing. Hold on, let me find it. Off screen because it's in my personal notebook thing. There was a link for a keyboard test. There it is. There we go. We're going to use this now. This is better. Put this back to that. Okay. Okay, that's the weird thing. So let's make this bigger so everyone else can see it. How do I clear it? Reset. I guess just reload. There. If I hold down Q and hold down W and press Q and release it, it sees a W down and then a W up, Q down, and then Q up, W down, and then finally I release W. Why would it see that? Yeah, I'm thinking too. Like, what's going on? So individually, the two work. Q down, Q up, W down, W up, W down, and then Q down gives me a W up, Q down, and then release Q. It's a Q up, W down. Okay, so it's not letting me hold Q and W down together for some reason. If I do Q down and then W doesn't work at all. Oh, okay, so Q is overriding W somehow. When Q is down, it can't detect W at all. Which is weird because I have it daisy chained. I have the row daisy chained over, but not the column. They're connected, right? Yeah. They're on the correct pins. That's weird. Brain is now like monkey with the symbols. Thinking how to think. Yeah, they're on non-O. So what would cause it, if you're holding Q down, what would cause W to not work at all? Or key 0. When we're holding key 0 down, key 1 doesn't work at all. Why would this not work if column 0... If key 0 is down, why would this not work here? Setting column 1 low, reading row 0. I'm pretty sure it doesn't have to do with putting the key code in the report. Because the other thing is, if you're holding down W and you press Q, the W goes up, even though we're still holding it down. I don't know. I'm thinking maybe it's just something weird with these GPIOs and I should pick different GPIOs. Using 8 and 9, right? They're not connected internally, I don't think. Let me make sure that set it up correctly again. D8, D9. And the common row is D10. Hey there, Mr. Balrog. No way to debug the key codes array? No, we can debug the key codes array. I think what I can do is I can have like a previous, yeah, let mute previous report. Need to type slower. And then down here, say previous report equals key codes. If key codes is not equal to previous report info keys colon question mark, right? Key codes. It's just I'll have to remember to bring up the serial port. Putty. Hold on. There's a problem. We can't do info inside of here. That will cause it to crash. Right? We can't. That will be recursive, I think. That's why I had to have this this thing here. Did I put it under state? Yeah. I guess I could repurpose report. Now let's do it. Let's just do keys. See, you have no clue how any of this works. Could it be that Q closes the circuit, therefore anything after the Q is not doing anything? It should only close one. These are two circuits, so there are basically two paths to the row. The column is the bottom, the two columns. So these two wires are separate. They're not closed. They're not connected at all, right? They're going two different GPIOs go to two different keys, right? The top one is the common row, so they're daisy chained back. So the idea is if you hold down one, it'll close the circuit, but only if you're driving the blue one, column 0, low. If both column 0 and 1 are high and you close the circuit, it doesn't matter because that means there's high voltage on both sides, and so you're just going to read high, right? Even if I press the button, it's still going to say high. But if you drive column 0 low and I press the right button, nothing happens because that's not connected. These two aren't connected at all. It's only when I press this button while this one is being driven low, does it now drive the row low, and then the row is what we're reading back. So that's my attempt to explain it. These should both be able to drive the row low only if their corresponding column is being driven low. Yeah, 3.3 is very high voltage. Of course. Okay, I put the keys there, and I need to initialize the keys. Yeah, so I need to do this similar thing here. Only it's keys. And then I gotta move this down to here. Oh no, this is pretty sketchy code, but that's okay. For key codes in port keys. Okay. So still same problem, right? Yeah. So let's see what the serial port shows. All right. Okay, we're only going to get the reports dumped every once a second. So if I hold down Q, so we see the key's 20, right? Release it, now they're all 0 again. Hold down the second button, it's 26. Release it, it's 0. So if I hold down the first button and then tap the second one, nothing happens. So it's like the second key is dead. Hold down the second key, tap the first key on. Oh, it goes momentarily, no keys down, and then left key down? Oh, that's weird. Then it goes both keys down, and then just the right key down. So 26 is W, and then the Q is 20. They both went to 0 momentarily. Why would they both go to 0 momentarily? Well, that's weird. Look at that one. I don't know, something tells me it's still a timing issue thing. Beep beep. Beep beep. 3.3 volts is a common voltage. The other common one is 5 volts. Like the USB is 5 volts, so there's like a power regulator here, and it steps it down to 3.3 and holds it steady. 3.3 is pretty common for small embedded things, and yeah, that makes sense that your Joule vape will also be 3.3 volts. Maybe get your DFO out of the way. What's baffling is that momentarily neither key seems to be down. What did you say that I ignored, Ender? Or are you just joking? The mod action? Should I have let you hit the mod action? I'll let you do it next time. So momentarily while both keys are down, somehow row 0 is reading high and high here as well. I don't understand how that can happen. Indeed. I wonder if it has to do with memory fencing? Like instruction reordering? Is it reordering the instructions here? I can put in a memory barrier just to be sure. Let me find out how to do that. That would be in Cortex M, right? Maybe Cortex M RT. Barrier? No. Maybe it is in Cortex M. Really? Rust Cortex M memory barrier. Oh, that's cool. I should be using this then. Right, it's not there, but it's in this AM. Okay, DMB, that's what it is. Data memory barrier ensures that all explicit memory accesses that appear in the program order before that instruction are observed before. Okay, let's try this. Let's add some memory barriers. So the sure. We'll put one. Let's put one around all of these things. Let's put lots of barriers everywhere. Barriers around all the things. Why not? Watch, this does absolutely nothing.
Ba-da.
I guess we can eliminate it as a suspect.
Ba-da.
Yeah, it didn't do anything. So it doesn't have to do with instruction reordering. Q. W doesn't work at all. W. I bet you if I flip these two around in software, it'll flip the behavior of the two keys. But why, right? There's some bug in those two that I'm just not seeing.
Ba-da. Ba-da. Ba-da.
Oh.
Ba-da.
That's weird. Nope. It doesn't matter, actually. So there's something, maybe there's something wrong with that GPIO, or am I not waiting long enough? Maybe 10,000 is not enough. Could put another 0 in there.
Ba-da. Ba-da.
Nope. That's not it. Barrier of data memory. Electrical interference happen if the wires aren't shielded? I wouldn't expect it to completely kill that signal. There's just something fundamental I'm missing here. I'll leave the memory barriers in there. Let's flash this one more time.
Ba-da. Ba-da.
Independently, the two keys work. It's only when both of them are pulled down together that it acts funny. Why would that be? Holding both down does what? Well, holding both down will connect both GPIOs together, but could that be it? Oh, wait a minute. Wait a minute. No, we're only driving one column at a time, so it doesn't matter if both keys are held down. We're never putting both low at the same time. But what if one's high and one's low? Aren't I shorting at that point? Oh shoot. I think that's what it is. I don't want them to be set high. I think I want them to float. I think we want to stop driving it if we're not scanning it. Hey there, Romania Hate. Yeah, if I'm driving one column high and the other column low, and I close both circuits, now I have both high and low connected together, right? Or they're competing. Yeah, okay, that's bad. I don't want to actually drive these high. I want to have them float. Is there a set something? Set high. Set low. I mean, the other solution would be to use diodes so that they can't drive each other. Oh, I hear the ice cream truck. I gotta take a break to get ice cream. As soon as it gets near my house. Which is very soon, I think. What I'm looking for is a way to set it to tri-state. Is it set drive strength, maybe? No. Probably not. What's set output override do? Enable output enable override? What does that do? Yeah, I gotta take a break. I'll be right back. Okay, he stopped somewhere down the street, so I have to wait a little bit longer. Mop garden emotes? I haven't heard of Mop Garden. Who is Mop Garden? These are great comments, aren't they? Set output override. Set the output override. What's an output override? Use the original output signal from the selected peripheral? What? Invert the output signal from selected... I don't know what that is. This is not what I want though, right? Is there like a set disabled or something? Set... What's the drive strength? Okay, it's just in milliamps. Oh, okay. I gotta take a break for a second. Sorry about that. I'm back. Turning cameras on again. Hey, look, you can tell I was outside. No, see, the ice cream is more important than the stream. Sorry. It's gonna take my glasses a while to untint. Okay, it's not set drive strength. I want to be able to, like, disable it. Disable? Set into floating disabled? Can I do that? That gives me a new pin though, right? Yeah, that consumes self. I can't really do that. I know FBI glasses. Yeah, my sunglasses. My glasses automatically tint in the sun. They make glasses that auto tint now. Ha ha, Endorn. Think reconfiguring the output takes way longer? Probably. Should I just look this up? This comes from RP 2040 HAL, right? So, hold on. Tri-state output. Will I stream again in 8 hours? What would be 8 hours from now? Maybe. If I'm not too tired, yeah. Yeah. I think normally it's going to be like Monday, Wednesday, Friday, but I missed this last Friday, so I wanted to catch up with a weekend stream. Yeah, I need to update that. I should probably say like my schedule is roughly Monday, Wednesday, Friday. I don't know what to do here.
Gosh, just pushed up.
So we could move the pin between modes. I would just have to put it into some container like an option, I think. See ya, Endurin. Hey there, Liquidor. How are you doing? It's been a while. Yeah, I'm doing something completely different right now. I'm trying to program the firmware for a keyboard. My 2-key keyboard. I thought I could get away without having diodes, but I'm pretty sure this isn't going to work without diodes. You know, the other thing I can just do is have just one column and 2 rows. The problem is my columns need, or the keys need diodes, really. Otherwise, one column can end up driving the other if you close a circuit. Or if you close multiple circuits, right? It'll end up having two different drive voltages from 2 different columns. So I'm thinking, without diodes, I just have to tri-state the columns I'm not driving. So I can see what let's see how this works. Let's see if we can make this work. So wouldn't I just make it a cell? No, I can use an option. Just say sum. So let's have them default into floating disabled. All right. So D8 and D9 are floating initially. Okay, so I'm going to want to copy this because down here where we're setting them, what we do here instead of let, we say column 0 equals sum call 0 dot unwrap into push pull output, and then as ref mismatch types. Is that because this thing returns a pin? Oh, it's a completely different type. Shoot. Ah. Okay, well we can have two different containers then. So these could be column 0 and 1 disabled. And then we have column 0 enabled. You know, my typing skills aren't very good right now. I don't know why. Alright, so then this becomes column 0 enabled equals, I think we would just do take, right? Disabled. Take unwrap. And labeled. Completely misspelled it. Okay, and then once it's enabled, we can set it low, right? As mute. Unwrap. It's a horrible way to do this. I should probably try to encapsulate this into another class. Okay, and then to tri-state it again, we would just say column 0 disabled equals a column sum column 0 enabled dot take unwrap into floating disabled. Okay, and I just need to repeat this. Let's just delete all of this. No, let's not delete all this. Take this and copy it. So we're doing the same thing for column 1 now. Coding with physical hardware must be fun and satisfying. I think so. The danger of creating short circuits and shocking yourself, it's always exhilarating, right? This code is really ugly and I'm gonna need to clean it up, but I just want to get it working. So now the idea is when we're not driving a column, we're completely disabling it. And when we are driving it, we're driving it low. So the two columns will never short each other out. Duh. Duh. Okay. Programming mode.
Ba-da.
Flash.
Ba-da.
Fixed. It's fixed. It's fixed. Yay. I wonder if that means we don't need those hard-coded delays anymore. That it was all just, I was just shorting pins together. So the left button is Q, down, up. Right button is W, down, up. Q down, W down. Q up, W up. Oh. Did we have a transient there? W went down a second time? Or is it just repeating? I think it was a transient. It's getting an extra W down. That might be an artifact of the way I'm doing the scanning. Let me look at my serial log here. So that's a 20, and then add 26, and then remove the 20, remove the 26. 26, 20 and 26, just the 20. Okay, so it is good. So it must be just something Windows does. We get a repeated key down on the key that I'm still holding. See that last one, that W down? It's just like an extra W down for some reason. But it doesn't translate into an actual key press, right? Oh, I get it. It's so that it can assert the key repeat. Yeah, okay. I think it's just something Windows does. QW for the win! What will the 2-button keyboard do? Type GG or EZ. There we go. Hey there, Apollo I. Instead of QW, I can make it EZ. Let me try to clean this up. I want to see if I can get away with not having these weights here. So first I'm going to check this in though. Not make this mistake again, right? We're going to commit this and say get 2 by 1 key matrix working. Push that. Alright, so let me remove some of these things. Like, I probably don't need this initial memory barrier. We'll leave a memory barrier there between setting one low and then reading the row back. You know, hold on. I think I might need that delay there, right? Let's leave that delay in there, but then take out the other delays. Like, I don't think... We don't need this memory barrier. I don't need that... Well, don't need that memory barrier. Leave that one in. I don't think I need this one. So we can enable one and disable one and enable the other. It doesn't really matter, right? Well, actually I think I want to make sure we don't accidentally drive two together ever. So disabling one first with the barrier and then enabling one is probably a good idea. Setting it low. I'm keeping that in, but I'm removing the barriers around this, right? And I'm removing this delay here. And then I found while I was looking at this that there's a delay here, right? Yeah, it just does the same thing I'm doing, right? So let me change this into a Cortex M ASM delay. And then put that one down here too. Let me just make sure this works. Reset board. Flash that. That other ding sound was my putty going down. Alright. I don't know why I'm using that. It's better to use this one, right? Looks good to me. I wonder if that's the rate we're effectively going at, 30 milliseconds. That seems to be the quickest key down to up transition that I can get. That must be our polling rate, 30 milliseconds. Probably has to do with this hard-coded delay in there, right? Now, can I reduce that down? Let's see what happens if I completely comment it out. Whoops. Huh? There we go. Build.
Ba-da.
Flash.
Ba-da. Ba-da.
No. It's hose now. We have to have some kind of delay in there. But how low can we go? How about to 1,000?
Ba-da. Ba-da.
Reload that. Huh, it's still 30 milliseconds. I wonder why. Maybe that's just the rate at which Windows is polling it? That could just be the rate at which Windows is polling it, right? Page up and page down could also be useful. One could be Control-C, the other Control-V. I thought it was, we need 3 keys. One is Stack Overflow, and the other one's copy, and the third one's paste, right? Let's go to 100 cycles.
Ba-da. Ba-da. Ba-da.
All right. Okay, yeah, that 30 milliseconds must be like the polling. Actually, what happens on my normal keyboard? Oh, that's faster. 8 milliseconds. Oh, the next thing I'm going to do is measure time. So either this keyboard is slower, the bus it's on is slower, or something. Do I care? Not really. I'm interested to see how low we can spin on the CPU here before we're reading the row too fast.
Ba-da.
Ba-da,
Ba-da.
ba-da, ba-da. Okay, that's too fast. We can see these spurious keys when we do that. Okay, so it's somewhere between 10 and 100. How about 50? See how we do this? Just keep guessing until we get one that find the edge, and then we're just gonna double it. This is how engineering works,
Ba-da.
right? Did that program it?
Ba-da. Ba-da.
Okay. It didn't. So now we're good. So 50 is safe. 25? Do I hear a 25? I should probably do this properly and name it like key scan delay or something. Key scan delay cycles. Put that up here as a constant somewhere. How about right here? Actually don't know what type it takes. U32. All right.
Ba-da.
And go until it breaks. Hasn't broken yet, so it's somewhere between 10 and 25. What's halfway between 10 and 25? 18?
Ba-da. Ba-da.
Oh, now it's breaking. Okay. Not all the time, though. So, halfway between 18 and 25 is like 21, roughly. I want to find that edge where it starts to work more reliably. And then I'm going to double it. And then add a little bit more. And then we'll call it there. No, it's still breaking. Okay, so halfway between 21 and 25 is 23.
Ba-da. Ba-da. Ba-da.
Now 25 it was solid. You bet 31, right? Okay, so I'm getting spurious W sometimes, but not very often. So I think we're right on the edge right here. Between 23 and 25.
Ba-da.
So that tells me 50 is probably going to be the number we settle on.
Ba-da.
See, now it's not glitching at all. Right? But I bet you once in a blue moon it will glitch. Okay. I'm going to double it and add 2. I'm going to put a note here, experimentally, on the breadboard. We started seeing glitches at 23 cycles. All right, now to clean this junk up, right? Let's get rid of this import, which we don't need. I technically didn't need that, although I kind of want to button this up into one thing. Indeed. Indeed. Let's make a type out of this, like a tri-state pin. Struct tri-state pin. Is it because 23 is a prime number? No, it's completely related to the strength of the pins probably, and also the lengths of these wires and their you know, their RC characteristics, right? Capacitance of the line, resistance, and what's the word? Like related to that is the inductance. So the longer it takes, the higher the, what is it? The higher the capacitance, the higher the inductance of the wires, the longer it takes for the signal to transition from between a 0 and a 1. And so, and also at what point does the input detect the difference between a 0 and a 1, right? Between 0 and 3.3 volts. All of those come together as, well, we need to busy wait our CPU at least 24 cycles in order for the new logics to settle to that, right? If we don't wait that long, then we misread it. We read the previous state. So hold on, this is enabled. I guess we can actually make this an enum. When it's enabled, we have a pin that's enabled, whatever that type is. It is going to depend on a generic, though. So we'll say pin or something. I need a unique name here. Which? It's a push-pull when it's enabled, and when it's disabled, what is it? It is a disabled floating. All right, and then let's implement that. Bet if there's effectively a way to ping to see what the ideal time would be through the circuit. The right way to do this would be to have an oscilloscope and then actually just show it and then measure it. But all this stuff is going to change when I put it, if I change to slightly different length wires, when I go to the PWB. So we'll have to measure it all again, right? Let's import pin from, yeah, out of fruit. He's not satisfied. Consider restricting it to that. Sure, we can do that. All right, output. Cannot find type output in this type. There's an enum variant. Okay, don't know about that yet. Can't find push-pull. Import push-pull. Import floating. Import disabled. And wherever this import disabled from, we'll import output. Actually, you know what I will do is we'll make it GPIO disabled. That's okay. We'll make it up. We'll wait until it collides with some other name. I forget, do I put it here? Yes. Function set high. Oops. Set. Actually, we're not going to use set high, right? I only really need set low and disable. And new, right? And how do we make these things? We get them from pins, right? So what does it state here? It's just a GPIO. Oh, it's actually a pin that's in reset. Okay. So then I should put that here, right? Wow. That was wrong. Can I just import reset? No, I guess I can't. I guess I have to do this then. Shoot. Is it just which reset? Consider further restricting the associated type. Okay, I don't know what this reset thing is. That's the problem. Let me click into it. Where is it? Here it is. Looking into macros. It's some ID as the pin ID reset. What is this? How about I click into floating? Here we go. Now let's look around for reset. It says, okay, it's a pin ID is associated type. Okay. How do I use the associated type? I think it was trying to show me that. It was like this didn't work though for some reason. The trait pin mode is not implemented for that. Do I need to like say this is also a pin mode? A pin ID? No, we don't do that. Whoops, we don't do that there. Do it here, right? Where? Pin mode, not a pin ID. This is so painful. Valid pin mode. Where does this valid pin mode come from? Is that because of pin? Yeah. Valid pin mode of that ID. I think I import that. Ah, my goodness. This is painful. I guess it's for type safety and all that. It's basically saying you can only instantiate this pin if it has a reset mode which is valid for that pin. Anyway, we want a self-disabled pin, right? Into floating disabled. And then that's it, right? Right, and then set low is it has to, oh wait, if I want to use it without having it transform itself, then I want this inside of a bigger struct, right? Okay, and then here's where I need to do like a cell. mode. I'll call it mode. Hey there, Epic Unknown. How are you doing? I made a 2-key keyboard. Look at that. It types Q and W. Trying to clean up my code now. In order to make this work without diodes, I had to have the pins go between floating and being driven low. And this is ugly right here, like where you take it out of one option and you turn it into a push-pull output and then set it low, and then when you're done, you take it out and you turn it back into a floating disabled pin. I'm trying to take that and button it up into a structure that represents a pin that has 3 states. You can either drive it low, high, or disabled. And the fact that the type changes between when it's push, pull, and floating is a tricky thing, right? So I'm putting into this enum where it's in one of 2 states, but then I want the outer struct to not need to return it to consume itself and return itself back out. I'd rather make it just mute. The method's just mutable, right? So this would be like mute self and not return anything. That's what I'm trying to get to. This keyboard now gets S key. People can finally quit Vim. That's right. This is going to be the quit Vim key, and this is going to be the Stack Overflow key. I wonder if there's an effective way to ping to see what ideal time would be through the circuit. Oh yeah, that's right. I already answered that. Okay. I think cell is the way to go, right? And I'll, this should actually be just that. I'm gonna have a cell and call it the state or something. So this will hide away the fact that that I have to keep transforming the type. So this will be state. Oops. It should just be self. And then state. And then this type here. And then an empty bracket there, right? I have to do cell new, right? Or is there an into for cell? There we go. There's an into. There's an into for almost everything. Looking like a great deal of weird type kung fu, doesn't it? This is just so that I can make the outer thing have methods that take the mutable reference and not transform it. So yeah, this is gonna panic if it's not in the correct. Actually, we can handle like if it's already in the enabled state, it just calls a method on it, right? So we would say match self.state dot take fill the match arms. So we have the enabled pin. So if it's already enabled, then it's just pin dot set low dot unwrap, right? And this needs to be mutable because set low mutates the pin, and then we put it back in. So we return self. Actually, I can cheat. Just copy this, and then this is enabled. And this just become, we don't need to transform the pin at all. Right? Oh, wait, what am I doing? It should just be self dot, yeah, self dot, how do you store into a cell again? Is it put? Take is to take out, but how do I, is it set? Sets the contain value. Yeah, there we go. And then I don't need an into, right? That's what I do, right? Yes. Only what's the error here? Probably because of this, right? So let's just copy this for now. Make sure that error goes away. The error didn't go away. Okay. Maybe because of this. Okay, here's where I need to transform it, right? This code I had down here. Into push-pull input. Push-pull output. So it's pin into push-pull output unwrap. And then it... Then we put it low there. Don't need to unwrap that. I need to mutate that. Actually, no, I don't. The type of the pin actually changes here. So this is let a new pin equal that. That needs to be mutable. Okay, what's wrong with this take here? The take exists, but its trait bounds are not satisfied. Why does it need to be default? Is it not take? Oh, that's not what I want. I don't want take. Shoot. Is it not cell that we can just complete? Maybe it's just option, right? Maybe that's what I want. I don't want cell. I want option. So then this becomes right, that this should be unwrap. So I'll always have something in it, and then right, instead of, so this will just be equals, right? Sum. So we take the pin out of our state, and then it's either already enabled, and we just set it low, and then we put it back. Actually, because we put it back, I can move this out, right? Still not into Rust syntax? I'm getting into Rust syntax. I like the challenge. I think that's what keeps pulling me into it. It's that it's challenging to write, but once you get it written, it looks really cool, and it usually works much more often at runtime. So to pull this out, I need to have this match return the enabled pin, right? So we'll just say let pin equal that, and then move this out. And then this will just return the pin. Actually, then I can just move that out. And this needs to be mutable. This does not need to be mutable. Right, so this is, okay, I got it. So this is where it's cool. Once you get it to where it's what you want, then it's really easy to read, right? So we take the pin out and say, well, is it enabled? Then we don't need to do anything. If it's disabled, we need to transform it into a push-pull output. Now, once we get that push-pull output pin, we set it low, and we put it back into we store it again, right? So we can make a high that does the same thing, only it is a high here. In fact, I could make then this could be two push-pull output, right? I'm going to leave it the way it is. And then if we set float, then we just reverse this, right? This becomes into floating disabled. And this just returns the pin back out, and we don't need to do anything here. This doesn't need to be mutable anymore. Right? And then this needs to be disabled. And there's where that type difference helped me out. It wouldn't compile with an enabled floating pin. Okay, now that I have this, I should be able to make a tri-state pin. So if I could get rid of this option, that would be cool, but I don't know how to do that. So we'll keep it in there for now. So yeah, so then the new code here will be let column 0 equals tri-state pin new pins D8. And then column 1 is D9. All right, and then all this junk here is just column 0 dot set low. And then this is column 0 dot set float. All right, and then we have column 1 dot set low. And this is column 1 dot set float. These need to be mutable. Now. All right. Get rid of this. I do have an unused method called setHigh. I am tempted to just mark it as allow dead code for now. Okay, and then this thing here. I'll clean that up in a second. Let's make sure this builds. Okay, then over to the keyboard tester. Q up, W up, Q W, Q up, W up. And I think I've decided that key down is something Windows is adding, because we're not seeing it in our keyboard reports. Q down, W up, Q up. W down, Q up, W up. Q down, Q up, W up. W down, W up, Q up. We're good. The quickest key I can get is 31.9 milliseconds, right? Not quite sure why yet. But that's the next thing I want to do after I clean this up a little bit more is I want to do some actual timing on the device side. Right, I can try to remove these data memory barriers. I don't think I actually need them. Looks good. So it looks like we don't have to do any deep bouncing, because I haven't yet seen a key that has repeated more than just holding it down, and I haven't seen any like missed key detections. Okay, we can get rid of that. We don't need our button anymore then. Where is this used then? Oh, we can get rid of this. I don't need this anymore, right? And then I don't need this GPIO 11. Okay. It can remove the data memory barriers that we had. You know what we can do is move the delay into the set low or the is low. Really, this delay goes with the is low, right? Because we're waiting for the signal change to settle on the input. Right? Cleanup time. That's right. But I'll be doing a little bit more. We're getting a warning on this line, and then down here for this. Okay, we don't need that I anymore. I want to clean this stuff up. One more data memory barrier. There we go. Okay, that's a good check-in point, right? Verify I didn't break anything.
Ba-da. Ba-da. Ba-da.
Q's and W's. Alright. Good night, Nui. Thanks for watching. Or listening. Or both. Checking that in. Git commit. Refactoring. The main thing here was to make the tri-state pin type, right? So make tri-state pin type to like encapsulate the code necessary to either drive an output pin high or low, or let it float. Remove unnecessary data memory barriers. What else did I do? I removed the... Hold on. Remove use of the bootloader pin. Bootloader button. Because, well, we have real keys. What else? Okay, I removed the report every second. Remove log message every second. All right. I probably should take that tri-state pin and move it into its own module just to keep main from getting too big. So let's do that. Tri-state pin. And then in main, we have a mod tri-state pin. And basically, I'm going to just cut and paste it. Cut. That wasn't cut. That's cut. Try to remember my hotkeys. That's paste. Okay, and then I think just to keep it simple, I'm going to take all my imports, copy them, and just delete the ones that we don't use. So copy them, and then here, paste them. Remove all these that we don't use. So yeah, all of these. Don't think we're using logger, right? Nope, not using. Okay, I am using something from embedded HAL there. I'm using the output pin, so using that. Not using any of that. Not using these, but we are using the GPIO ones. Not using the clocks and not using logger. I ate a bracket. There we go. Cool. I think I need to make this public, right? And then these methods all need to be public. And then we just need to use down here. Or import. Okay, and now I can delete all these. Alright, make sure that I didn't break anything.
Ba-da. Ba-da.
Q, W. Check this in. Git commit this. Extract tri-state pin type to its own module. Okay, now I think I want to do a little bit of time measurement. I want to understand how the timer thing works. We're using it right now with start and wait. I want to see the implementation of this though. What is this type? Countdown? Okay, here it is. So there's a get counter. I think we can call that, right? Because wait. Okay, it gets the counter and then it adds the period that I give it. And this self time is a count of microseconds. So I think it's just like it is on the Raspberry Pi Zero. The timer is counting microseconds. So if I go on that 0 embedded time. Wow, this is... Yeah, so it's just a new type for... What is that? U64. So it's a 64-bit counter of microseconds. And then the wait just pulls, it just samples the counter, and if we've reached it or passed it, then we return okay. Oh, that's interesting. So we can actually wait for it multiple times because it advances by the period again. Yeah, so I didn't need to start it inside here. I could have started it outside. Well, anyway. Yeah, so I think I can just call get counter myself then. All right, then can I give it to my logger? Hold on. I can't log within here anyway. I'm doing it out here, and that's once a second. Where do we do the USB polling? Right here. Here's where we do the USB polling. I forget. Why can't I do a log from here? Oh, I can't do a log from here because if I write to the log, that one tries to borrow the serial port, which we have already borrowed here. Wait, but this borrow is released when this interrupt free returns. So I should be able to do a log from here, right? How come I couldn't before? I can't remember why. This serial, right? The problem is borrowing the serial port. I can't borrow it twice. I don't know. Let's see what happens if I try to do a log from here. That was like this, right? So if I just comment that out and then instead do that. I don't need to do that. This builds, right? Here's the test.
Ba-da. Ba-da. Ba-da.
Yeah, it didn't freeze. Okay, so I can do logging from there. So as I press it, so now what I want to do is actually include a timestamp for these messages. Right?
Beep, beep.
Beep, beep. So for that I need a timer. Hold on. Can I just borrow the timer in the logger? Let's see. Where do I make the logger? I don't remember. Down here. Right, so can I just kind of borrow the timer? What type is that timer? It is of type timer. So then here, I can just give it a timer. It has to be static then, right? Because it's going to live forever. All right, then timer comes from the HAL. Wait, what? Sync is not implemented for pointer to constant. What? There's a phantom data inside the timer? Wow. Okay. Why did they do that? Okay. It said that, yeah, it's got a phantom data. And that's not send and sync. Why did they do that? I have no idea. Oh, it's probably to prevent it from being shared. Because that would be dangerous. Okay, I can understand that. So then, if I really can't share the timer, why don't they let me share the timer? Because we can It's got interior mutability or something. I don't get it. Why is timer marked like that? I guess it's because it's has access to the register block. All right. So then I guess I'm doing this stuff again around it. Yeah, that's what I gotta do. Gotta put it into a mutex because it has access to hardware registers. And it's not thread safe. We have to make it thread safe. Okay. Yeah, so I gotta do the same thing to the timer that I did with this serial port. I have to box and leak it. Box and leak the timer. So does that mean I do a clone here? I forget. What did I do here? What is... Oh no, it's a reference. So we can just borrow it. Why not? Hold on. That should have worked. Oh, why didn't it like that? Mismatch types. Expected a mutex found a reference. Why did it expect well, yeah, that's true. Hold on, I did the same thing. Box leak, box new. Oh, I forgot these ones. We have to, yeah. I forgot. Not only do we have to box and leak it, we have to put it inside of a ref cell and a mutex. There we go. Yeah, so then whenever we want to use it, we got to borrow it and then borrow mute it. What a pain. Right. This is to make it completely safe, right? Oh, this is a problem. We give a reference to the timer to the NeoPixel. How does that work again? This countdown, how does that work? It does take a mutable reference. Wait a minute, so how is it able to share the timer then? This countdown, how does that work? How does it have immutable reference? Okay, I'm really curious how this works then. Oh, there's a get counter. Ah, okay. It doesn't need mutable reference to just read the timer. I see. Well, then can't I just do the same? Can't I... just pass a immutable reference to the timer because I don't need mutable reference? Hold on, then let's try that. Let's change that type. To just that. No, it's just mutex then. I don't need the ref cell. No, the mutex is going to require that I lock interrupts though. Shoot. Okay, then I'm gonna not do this. Instead, I'm going to hack it. It's gonna tell me it can't do this because it's not send and sync, and I'm gonna tell it it's send and sync anyway. Trust me. Yeah, we're just gonna say we're just gonna give it the marker. Unsafe impl. Is it send? For logger. Try to figure out later why I needed to do that. Is it send and sync? Or is it just sync? It's both. Don't try this at home. Yeah, back up here, then I don't need to do any of this garbage. Can I just undo this? Yes, I can. And then you just get a reference to it. Oh, I still need to box and leak it, right? Otherwise it's going to say it doesn't live long enough. Yeah. Box leak, new. Basically moving on to the heap and leaking it. Because our logger has to have static. Makes me think that log is such a pain in the butt to deal with. I might as well make my own log trait or macros or whatever. Okay, I thought I just made it live long enough. What's the problem here? Do I need to say that it's for static? Yeah. For some reason it defaults to a shorter lifetime, and I have to say no. Look, I want it to be for the static lifetime. Oh no, that's why. Right, it's because I've had a reference to a reference, so I don't need that anymore. The real bug was I had a reference to a reference. There, if I do that, that's a reference to a reference. It's no longer static, right? And that fixes it. Okay. Okay, so now the logger has it, so now I can use it here. Right, and I had this here, so I'm gonna put that back in. It was my other project where I had the format here. What did I have for that? Right, we want to get the start count too. I'm just gonna cheat and open that. New window. Open. It's my bare metal project. In the logger there. So yeah, it had to start count, which is a U64. Hey there, Matthew. How are you doing? I'm doing well. How are you doing? Just doing some bare metal programming here. Get counter is what it is. Right, so we sample the counter by calling get counter, not sample counter. Then we get the now is the time between what the counter is now, subtract from that what it was when we started, and then I'm going to use it here. Right, formatted in. Oh, I had to have seconds from microseconds. Oh, okay, because I was using floating point. I don't know if I can use floating point. So let's just change this then. Instead of a floating point 6, we'll have some number dot and then some integer and then some other integer, but 0 padded to 6 characters, right? And then I'll have now seconds and then now microseconds. So then let now microseconds equal now divided by 1 million. Right? And then let now seconds. That should be modulo, by the way. Modulo is that one. Wasn't it just divide then? Yeah. Let's try that out.
Ba-da.
Flash that puppy.
Ba-da.
Okay. And then let's run our serial port. Here it is. There we go. So it's seconds and microseconds. Hey there, Ernius. Passed lots of time since last time. Yeah, I've been working. I didn't leave the job. It didn't allow the job didn't allow me to stream the game I was working on. I was able to stream Advent of Code, and this project has nothing to do with what I do at work, so it's safe too. And work was just keeping me busy, and also I really couldn't think of a project that would be fun for me to do on the stream. So when I came up with the idea of doing a keyboard in Rust, I'm like, that sounds fun. Let's do that. It does look like it's about 30 something, or maybe it's at 26 milliseconds is the shortest I can get it. 20 milliseconds there. Oh, there we go. That might have been a transient, right? That's where it saw the key and then 800 microseconds later it didn't, and then it saw it again and then it didn't. Okay, that's much shorter than 30. What was that? No, that's around 30. 411 minus 378. 8, 9. Yeah. Trying to see how fast I can press these keys. Oh, there we go. Somehow I did that in 6 milliseconds. I'm trying to see how fast I can hit the key. So that one was 10 milliseconds. Okay. I'm kind of curious how fast the polling loop is going. Like what the FPS is, right? Not FPS, but number of scans per second. So how would we measure that? Probably just having a counter and then every second printed out and then or maybe I can include it with this report somehow. Yeah, let me try to include it in the report. So to do that, actually, first of all, I can delete all this stuff. We've figured out we don't actually need to put that in the main program. So I can remove from here this keys. And I can remove that. So does that mean I can move that back into here too? That's what it seems to me to be like. So let's do that. So I would take that and do that. And this becomes what, data? And I can just do that. That's bytes, actually. I'll make sure that this still works.
Ba-da. Ba-da. Ba-da.
Yeah. It didn't crash. Still blinking. I do need to restart the serial port, though. Every time I reset the board, I have to do that. It's just a pain. So... there's our reports. So if I hit caps lock on my other keyboard and the caps lock off... oh, that's the wrong thing to report.
Beep, beep.
Anyway, it was data, and I don't need this bytes, do I? I can just say if this is okay. Or is some, right? Is okay? What was it before? It was okay. Okay. Yeah, I don't need this state reports junk. I don't need any of this. I don't know. I wonder why I thought I needed that at all. Everything okay? Yep. Build that.
Ba-da.
Oh, I have a compiler error.
Ba-da. Ba-da.
All right, serial port. Here you are. Oh, that's interesting. I didn't think it would be that many bytes. Oh, shoot. I wanted to limit it to the... okay, I wanted to limit the number of bytes. Right, that original code limited it. Let's just bring it back. Yeah, this. So, I do want that bytes because I want to slice the bytes. Like that. Yeah. Size cannot be known. Can I just reference it? Yes, I can. Let's get rid of all... oh, we don't need vec or vector anymore. Flash it.
Ba-da. Ba-da.
All right. Cool. So if I turn on caps lock, it's 2, and if I turn off caps lock, it's 0, and if I hit a key, we see the key on and off reports. Cool. All right, then
Beep, beep.
yeah, I do want to see what the polling rate is. So to before I do that, I should check this stuff in, shouldn't I? So this is all just include time since boot in log messages. Duh. How long have I been going? 2.5 hours? Wow. Okay. I don't need this previous report, do I? Oh, I do. But I don't need this line. Okay, I need that previous report. Okay, so I think what I'll just do is have two things. The time that we started counting loops. So this is count start. Actually, I can just have it get the time right here, right? Get counter. And then have a loops or count. Loop count? Count. Actually, this should... No, it can go outside, right? So basically every time that I hit a key, I want to see that report. So it would be like some number of scans per second, right? So here we'll do let SPS equal timer dot get count wrapping subtraction of count start. How come it's not helping me auto-complete it? And then I want to divide that into the number of count, or count divided by that, right? Actually, this would be SPUS. To get it to per second, I'd want to multiply by 1,000,000, right? Because this counter will be in microseconds. So if I then multiply by 1,000,000, it'll be per second. And then when I do that, I want to... Actually, I want to get the now, because I'm going to set the count start to now. Basically reset it. Right, so count start equals now, and then count equals 0. Cool, so every time I hit a key, it's going to get the counter, calculate the number of loops we did, basically since the last time we reported or when we started. Divide those two to get number number of scans we did per second, and then reset that. So I need to increment the number of scans. We should do that at the very beginning here, right? So count plus equal 1. So then let's name that something else. Let's name it scans or num scans. Scan count. And that's my hotkey is not working. Okay, so this would be scan count start. All right, let's see what that gives me.
Ba-da. Ba-da.
All right, serial port. So it's counting, so every time I hit a key, wait a minute, why did it have such a low number to start with? Why? I kind of believe this number, 50,000 samples per second. That sounds reasonable. But why would I have such a low number to begin with? That's going to bug me until I figure out why. So we get the timer and start at 0, right? And we do that again every time we hit a key, or the key state changes, right? We get that timer, and then we reset it here, right? Oh, this should be just now. Maybe that's why. Probably not, but who knows? I do need to fix that one Windows sound that this still makes to be custom, so it doesn't make people think that it's their computer. There's that 41 again. Why? Why such a low number? I don't trust this now.
Beep, beep.
What if I print the other numbers? How about now and count? So we'll just print them. Hey there, Desert Tiger. Irish John Games. Thank you for the raid. Look at my cool new keyboard. It's got 2 keys. I can press this key and does a Q, and this one is a W. Yeah, I'm building up my own keyboard. Right now I'm at the prototyping stage to make sure that the code that I write in Rust to do key scanning actually works with real keys. And this is running on the microcontroller here. It's Raspberry Pi microcontroller. So the main difference, if you've seen the Rust programming language, the main difference between like a regular program in Rust and one that's running in a microcontroller is this first line here. This says we're not using the standard library. We're in an embedded environment. Yes, this one is going to be my Stack Overflow key, and this is going to be my I don't know. Really, you need 3 keys: Stack Overflow, copy, and paste, right? I guess for now it's just copy and paste, and I'll have to manually go to Stack Overflow. So right now I'm working within this loop function, which is essentially our idle loop. So within the idle loop, I'm doing the key scanning here. So the top wires are the row, which is an input to our microcontroller. And these 2 separate wires that are not tied together are the columns. So it's a 2-column by 1-row keyboard. And the way it works is the row is an input. The columns, you drive 1 at a time, low. The row has a pull-up resistor. So if you're not pressing any keys, the input will be pulled up to the 3.3 volts. The moment you press a key down, it closes the circuit, and whichever column you are driving low or grounding will then, if you're completing a circuit by hitting a key, the row will be grounded too. So to scan to see if key 0 is hit, we'll drive column 0 low, and then see, well, is the row low? If it is, then we press the left key. Then we let it float again, that column 0, and then instead we'll drive column 1 low. And then again, we reread that same row, and if it is low, then we have key 1 pressed. So once I get this working, to expand a keyboard of any size with this matrix scanning, you just add more rows and columns. Every time you scan a column, you would read all the rows, and then depending on what lines are showing up as ground or 0 volts, tells you which keys are being pressed. This is a Raspberry Pi microcontroller, RP2040. Hey there, A squared. So you guys know about Raspberry Pi, right? Well, Raspberry Pi made a microcontroller now, and there are several boards that use this. I'm using the one from Adafruit, the KB2040. But it's really cool because the RPRS group, like a bunch of people who have made a lot of libraries in Rust that run on this microcontroller. So I'm using them. Among them are this Cortex-M and the board support package from Adafruit, which is a pretty smallish wrapper on top of the RP2040 hardware abstraction layer, which basically they've written all the code to use all the onboard peripherals of that microcontroller. So all the clocks, all the pins, timer, this is the programmable I/O. PIO is a programmable I/O. SIO is, I guess that's serial I/O. But things like the USB, people have written drivers for that. And the hardware abstraction layer handles the connection to the actual, well, not the connection, but the register mappings and meanings to map to the USB device traits. So all I needed to do to get USB working was to do this, was to make a USB bus and say, hey, we want a keyboard, we want a serial port, and here's our product ID and vendor ID. It's the Rusty keyboard. This is a composite device, so our class is 0, and we want to include the interface associated descriptors. And now it's a keyboard and a serial port. And how am I finding Rust? Still loving it. It's very challenging, and I love that kind of challenge. Embedded Rust is a little bit weird in that you end up kind of breaking some of the code safety features of Rust on purpose. Like this, for example, is how I am hacking my logger class to say, hey, don't worry, we're thread safe, even though we're not. But it's okay because we're only using one CPU core and we're not running an operating system, so there's no task switching, there's no threading. So I have to just tell Rust, the Rust compiler, don't worry about it. I'll make sure it's safe. You know, this is essentially saying that this logger class is thread safe. You can send a logger to another thread, and you can share a thread. You can share a logger between two threads. We can't really, but this quiets down the compiler to make it pretend that it is. But other than that, like here and there, we have to use unsafe. But other than that, we get the same kinds of compile time checking. So lots of types are used to make sure you don't accidentally use like one pin where another one needed to be. How do I show that? Probably by mousing over this, you can see like the type of the column 1 is a tri-state pin for GPIO 8, and column 1 is a tri-state pin for GPIO 9. So these two pins, even though it looks like we're just picking different pins off of the edge of the board, they actually have different types. So I can't accidentally assign them to each other or use one where the other one was expected, that kind of thing. Things could look a little weird when you have like drivers that have a lot of requirements. So this is the driver for the LED, the one that's blinking purple there. It's a NeoPixel. WS2812 is the code name for it. So it needs the pin connected to the NeoPixel, but it also needs the programmable I/O block, and it needs a state machine, and it needs to know the frequency of the peripheral clocks, and it needs timer. And you button that all up, and then you can just, at the very bottom, you can just say, write this color, and then write this to turn it on and off. And while that logger thing is incorrect, it's only a problem if two things try to access it at the same time. And just don't use it inside interrupts. Oh, that's right, A squared. That's why. I can't log inside of one of these. That's the deadlock I was running into the other day, right? I can log like right here because I'm not logging interrupts at the time. Now that makes sense to me. Yeah, so there's some weird things in embedded software. So you can't use a traditional mutex. Instead, like you'd use something like this, where you're saying to the hardware abstraction layer, hey, I would like this closure to be executed while interrupts are masked or blocked. So I don't know why they call it free, but maybe they're saying that this code is interrupt free, like you're not going to get interrupted. The reason you do that is your interrupt handler might go and change some of the hardware registers too, and you don't want that to happen in the middle of you using it. So that happens a lot in this embedded code. If you have multiple cores, then it's not enough to block interrupts from happening. You also have to have some way of communicating with that other core to say, hey, back off from that serial port right now. I'm using it. So we'll get there later. Or you can always just agree beforehand in your code that these two CPU cores are never going to share the serial port. So then it's kind of like having two threads, but not having them share variables. So yeah, today I was basically making the key scanning work, and I kind of went over how that happens. How we get it over back to the computer is through a keyboard report that we give to the human interface device class of the USB stack. And essentially it's placing a report in memory so that when the next time the host, the PC, asks for it, we say, hey, yeah, we have one for you. And I believe it's on the order of hundreds, if not thousands of times per second that the PC will check to see if there's a report available. I was interested to see how fast we actually are polling the keyboard. So I was printing out these numbers here. Yeah, so I'm printing the number of seconds and microseconds since the board was started, and then here's the keyboard report. 20 is Q and 26 is W. And yeah, so here's the number of microseconds, so that should match that pretty closely. And this is the number of loops we did, and then this should be this minus the previous count divided into that, I think. But I didn't trust this number, so I was printing out these numbers and then seeing if the division is correct. I mean, it looks reasonable. So it really is polling at 51,000 times per second. Deadlocking is the ideal case for this. Yeah, they call it spin locking, right? You're not dead, you're just spinning and waiting for the other guy to get out of the way. Or you agree to receive a message on some mailbox when the other guy's done. I'm wondering why sometimes it doesn't... Oh, I must be hitting the limit to how much buffer we have for the serial port. Okay, that's kind of funny. So we're basically printing too fast for the serial port to keep up. Okay, let me reset the thing.
Beep beep.
Beep beep. There's the reset button. Okay, and then hit the key. I'm trying to figure out why the first time it says it's only 51 scans per second. 277, okay, I should be printing out two numbers here, not just one, right? That's the problem.
Beep beep.
I need to like print out the count and then the previous count. Counts, maybe? I wonder if it's this wrapping sub that's the problem. So it's now and then scan count start. Did I close the serial port? Yes, I did.
Ba-da. Ba-da.
Okay.
Ba-da.
Open up the serial port again and hit a key after I make this wider. Wait. Hold on, did I print the wrong things in the wrong order or something? key codes now. Oh, I did print out. I did the wrong thing. This shouldn't. Okay. Yeah, I did the wrong thing here. Okay, so I just need to look at the numbers. This. Okay. It's this minus that. This minus that. That number is low. So why did it come out to be 43 though? Wait a minute, that shouldn't have been 346. That should have been much higher. Why is it only 346? Why does it feel like you haven't streamed in a long time? Because I haven't. This is the 4th stream in the last week, but before that I hadn't streamed in several months. You could try a checked sub on wrap to panic on overflow. But the 64-bit counter overflows, I think, what is it? After a million years? I probably don't even need to worry about it. I think it overflows. I did this calculation the other day. 32 bits it'll overflow in a couple hours. But when you add 32 more bits, it's like millions of years. Well, thank you, Chartinizan. I'm probably saying your name wrong. Sorry. Chartinizan. This 346 is too low, right? Why is it only counting 346? So that number is this scan count, and I increment the scan count at the top of this loop. And if it had been going for 8 seconds, that should be a very high number. So what am I doing wrong here? I wonder if it has to do with the fact that the USB starts in low power mode, and then it waits for the first report, and then it happens a lot. That might be it. It might be that. So what happens? So what I'm doing here is I'm asking the USB stack, hey, poll to see if we need to interact with the host, right? And it says, well, if we do, then we're gonna do stuff. We interact with the host here when we there and one more place here when we're telling the host what keys we're pressing, and here we're saying if the host has changed the lights on the keyboard like caps lock, then we report them too. So maybe when it first boots up, this is in some kind of low power or slow state, and then when we hit the key, we wake up the host, and the host says, okay, now we're going to poll you a lot more frequently. I wonder if it's something like that. I don't know, but I do want to fix this. I'm going to pull that back because I don't need all that stuff again. I just want to see the scans per second again. That's the correct code, right? So scan count turned into seconds divided by microsecond difference. I'm going to move that down to there. Close the serial port first.
Beep beep.
Beep beep.
Ba-da.
What I'm doing there to program it is I have to hold down this bootloader mode button, and then I have to toggle this reset button, and then my Flash script turns the build we made from ELF format into UF2 format, which is a special kind of data file for a UF2 bootloader. It's a kind of bootloader that Microsoft came up with, where the microcontroller through its USB interface looks like a mass storage device. So it shows up as like this a drive. For me, it's the letter F. So I copy it to the F drive, and then the microcontroller's mass storage device implementation is programmed such that if you ever try to write a file to it that ends in .uf2, it says, okay, this file must contain a new program that I need to load into the flash, and it does that. And if it's all successful, it then resets, and then your program's running. So it's pretty convenient. I just do build elf to uf2, and then copy that uf2 file to the device, and it's pre-programmed. Still using a split? Yeah, my old keyboard now is this Corn split. Wrong window. So I'm on this Corn keyboard using Colmax, so I'm a little bit slower and I make a lot more mistakes. Still, I've been practicing for 6 months and I'm still kind of slow. Okay, I was going to load this in and then hit the keys. So yeah, it looks like at first, before we hit a key, we're not actually scanning very quickly because I have it tied into the same condition that USB is ready. But once we do hit a key, it starts to scan very quickly, and it's on the order of 45 to 55,000 loops per samples per second. It's pretty good. This is a pretty responsive keyboard. What is 1 divided by 45,000 anyway? My calculator. 1 divided by 45,000. So every 22 microseconds? Is that right? It's hard to do math in my head. I think that's right. So it's scanning the keyboard every 22 microseconds.
Beep beep.
Beep beep. Or might be off by a factor of 10. If it was 100,000 times a second, that's every 10 microseconds, right? Yeah, so that's right then. Okay, let me include this in my version control. I'm going to say count or measure the keyboard scanning rate. Really, it's not the keyboard, it's the key scanning rate. And, yeah. Report scanning rate on every HID report. All right. Do I want to do any more work today? It would be nice to clean up this junk where I kind of have a sloppy array here with a index, and then I'm basically collecting keys. I should probably do something where I have a type that just says add key to report, and at the end I can just ask it for the key codes out, right? So how about I'll just do this the right way. I will make a HID report. Actually, it's a scan key code report, right? Let's just call it key codes. And in main, I will have a mod key codes. Okay, and then we're gonna have a struct key codes. Okay, so here, let's put the array. So key codes. is a U8, 6 of them. And then let's just have a next, which is an index usize. Okay, and then implement key codes. I need to make this public, by the way. Let's... Actually, I don't need to make... No, I do need to make one method called like add or something. And it's going to take a key code. Key code U8. This should be a comma. All right. I'm going to take that 6 out. Const max key codes. Usize equals 6. If next is less than that, then self dot, okay, this should be mutable self, by the way. Self dot key codes self dot next equals key code, and then self dot next plus equals 1. All right, now let's implement some traits on this guy, right? Implement default for key codes. Should be self.next. So key codes is just going to be an empty 0 for max key codes. Next is going to be 0. Actually, I wonder if I even need to do that. Maybe I can derive the default for that. I probably can, right? So the way to do that is derive default. I don't need that. And the other one I want is, hold on, what's the warning here? Never read, right? I want to implement from. Is it from that we want to implement? One should always prefer implementing from over into. So I want to implement from key codes for just U8. U8 max key codes. So from key codes, it's just key codes are key codes. Cool. So now back here, I can clean this up a little bit. This let mute key codes would be just key codes default. And don't need a integer there anymore. So then this is just a key codes.add 20. Making so many mistakes in the keyboard, it's embarrassing. 26. Okay, now here I just say key codes into. Expected, oh, right. Like that. Problem is this. I guess we'll just do this before. Let's put a comment here. Log any report change. So I will need to implement the comparison, right? Oh, and I also need to implement the debug trait. Okay. Oh, thanks, Irish John. Have a great day. A great evening, actually. So, I need to make it comparable, right? So, that is... what is it? Partial equal? For key codes. So I don't need to compare the nexts, right? That gets rid of that problem, right? Okay, previous report needs to be also a key codes default. Right, and then I need to implement the... Okay, there are a couple things here. I need to implement the debug trait, and also it's probably going to complain that that I moved it. Like, when I do that, then this is going to complain about that. So I need to make it copy, and I need to make it debuggable. Implement debug for key codes. And this is going to be format. It's like use alloc format debug, right? Okay, and then it's basically going to be right to the formatter self or self dot key codes. I think that's all they want to do. Basically, this is a thin wrapper for that array, right? Oh, maybe, is it F not right? I forget how to do this. How do you just... Wouldn't it just be FMT? I know. It's just self.keycodes.fmt. F. Because it's debuggable. Alright, and then the other one was copy, right? I think I just make it copy by just saying derive copy. It'll also want me to derive which one's first, L or O? L. In order to derive copy, you need to derive clone. There we go. Warnings are done. But A squared, doesn't that invoke some extra code? Isn't it more efficient to just do that? It's in core? I thought it was in alloc, the debug trait. But yeah, your way would work, but then this doesn't need that static string, right? Okay, just try it out. Build. Forming machinery is hot garbage anyway. And this is spoken by a Rust developer, right? There we go. Still works. Cool. I cleaned that up a bit. Interesting. The samples per second is smaller sometimes.
Beep beep.
Beep beep. Let's check that in. So git commit. This is really refactoring, right? move or extract out code that builds key codes array when making a keyboard report, or making an HID report, a keyboard report. Depends on how well the compiler is feeling, it seems like. Yeah. All right. I do kind of want to separate the concerns of the USB here from the keyboard scanning, but to do that, we can't just push the report. We'll have to make a report available, and then when the USB is ready for it, we would push, right? And this can fail if it's not ready, right? It tries to write an input report. Yeah, so there's a buffer, and we can overflow it. And also this write can return would block, right? If it's full. Okay, this shouldn't happen. This only happens if we gave it too much data to serialize. Okay. If we give it too much data to serialize, it'll... This shouldn't happen, but this returning would block can happen. So I don't think it's likely that we'll have keyboard reports faster than the host can report them, so I'm not going to worry about that. I think what I'm going to do is just have a single report buffer. So that is whatever this type is, keyboard report, right? Might as well just put it here, right? Keyboard report. Well, it's going to be a none to begin with. Okay. This is going to be service the USB bus. This will be scan the key matrix. So if ready, it would be if let some keyboard report equal keyboard dot as ref, I guess. Then we would try to write it, which is this part. State.hid.push input. So this would be if this is okay. Then we would want to set this to none. Or is it better to take it out, try to push it, and if it's error, then put it back in? Yeah, maybe it's better just to take it out. If there is something, then try to, so this would just be report. And if it's an error, then we put it back in. Is it set? Import. It's not set. It's just equal. I thought it was set. Is it put? I can't remember option. Go back to my cheat sheet. Option. Wait. Right. It's replace, I think. We get the thing up, we don't care, right? Okay, so take it out. If we can't push it, replace it back in. Okay, so this will be try to send the host the last keyboard report, if any. Okay, so then when we get down here, instead of doing this, I just want to say keyboard report equal. Actually, this would be also a replace, right? And then this actually, I had to move this in here, but I have to change it slightly, right? So I also will have a, I guess I can put it out here, outside of the interrupt free. So let host report equal none. I'm mildly surprised that works and doesn't yell about borrows. I'm not borrowing though. I am taking it out and then putting it back in. Okay. Right. So if we pull something from the host, then I want to make host report replace. I guess we'll just put the whole data array in there. And we'll well, hold on. I want that and its length. Well, can I just make it a slice then? I can make, no, I need it to own it. I need an owned, so I guess the thing is to just make a tuple, right? The array and the number of bytes that are valid in it. And then down here, we would say, if let sum data and bytes equal host report dot take. Do I even need this to be an option? I guess I do. Well, I'm going to just consume it, right, at that point. Then just log it. Yeah, there we go. Oh, I have an error. How did that get in there? I have no idea how that got in there. Can't borrow it as mutable. Can't borrow it as mutable. Why does host report? Oh, right. It needs to be mutable. Starts out as none, but might be replaced by a tuple. Okay, looks like we're good.
Ba-da. Ba-da. Ba-da.
All right, let's see if host reports work. Yep. And they're instantaneous, which is the cool thing. It's not every second that it happens. Oh, wow. It was able to scan a lot when USB was in low power state. That makes sense. So at first the keyboard is like able to do scanning a lot more because the USB is not taking a lot of cycles. But then when we start to do reports, then I guess USB is taking more and more time. Oh, I think we had a spurious key there. That actually might be a bounce. Right? Because look at that. With less than a millisecond, we had on, off, on, off. Okay. That's the actual on, probably. Okay, so we had a bounce here. Look at that. So I pressed the left key and then released it, but then there were two transients right afterwards. Right? So I guess I do need to do some debouncing. So we would just ignore... So I think the trick with this, right, is whenever we see a key go on, we need to see that key remain on for a certain amount of minimum time, right? So if it goes on and then off immediately, and then on and off immediately, we just wouldn't count these. I wonder if I can get that to happen again. If I, like, ride that edge of the key. Oh, there. I got it to happen again. Right about here. There's a transient. Right? On, off within 0.2 milliseconds. And then on again. So this would be seen as a double press, where really it was only a single press and release. The take mutably borrows the option? I thought take removes it. Hold on, let me look at take. Maybe I don't understand take. Takes the value out of the option, leaving a none in its place. I don't think it borrows it. It returns an owned T. Oh, right. You're right that it mutably borrows it in order to dig in there and take it out. Yeah, it doesn't. The lifetime doesn't continue to the return value because it's an owned value we return. Yeah, doesn't hold the borrow exactly. Whereas asref would, right? Or a get. Yeah, get. Insert. Am I in the same type here? Anyway. Yes. We could have a lifetime inside of an option. I can't even wrap my brain around that, A squared. I have a hard time with... I have a hard enough time with lifetimes as it is. 3.5 hours. I should probably bring this stream to a close, right? So, what did I do? Got key scanning working. I separated the concerns of the USB from the rest of the key matrix, which means I could probably put these into functions that do it for me and clean this up more, but I don't feel like doing that right now. We're not handling modifiers yet, but that's because I only have 2 keys. Q and W. Our main loop is nice and pretty again. Everything is handled basically in our idle, which is this thing. I really should just call it idle, IDLE, instead of delay milliseconds, right? Idle for 500 milliseconds, and during idle we check the keyboard and we check the USB, is what we do. Let me look back at my notebook. So this is basically done. I just need to expand it to more keys. This we'll have to do. And this is one of the next things I want to do is how to write Flash. Actually, I found in the datasheet for the microcontroller that there are boot ROM functions we can use to do it for us. So I want to play around with that. This is probably what I'll do next time. I'll play around with writing to Flash. And the goal will be that I can write a program that'll just flash it for me in place. I don't have to use the original bootloader anymore. That would be cool. I won't need to use the UF2 anymore. I would just burn straight from ELF or something, or from Hex or whatever. But probably I'll just be end up playing around with Flash. And then when I get a second controller wired up, I can work on this thing. I was looking into what protocol to use for the TRS link. Tip ring. I forget what S stands for. The audio cable that has 4 conductors in it. You could use UART, SPI, I2C are the 3 main ones. And I was thinking about using SPI because it's the fastest. But I'm not sure yet because I think... What was it with that? We would have to have a protocol to recognize when we're actually sending something. Otherwise, it's just a stream of bits, right? Anyway, I'll look into that later. We'll just leave it on this page while I check and see where we're going to rate. Chris is still growing. Let's rate him. Yeah. Alright, that's what we're going to do. He'll end up lurking himself, maybe. Okay, beware channels intended for mature audiences. I will probably be back tomorrow. I'm trying to get and stick to like a Monday, Wednesday, Friday schedule, but hope you enjoyed the stream today. And I'll see you next time. Okay. Thank you, everybody, especially A Squared and everyone else who's helping me. Bye-bye.